that take limit to each of them separately. Okay? Using the shortcut again. Highest degree term is its n power 2. Then the first part, if we take the limit, it would turn to like 1/3. But second part, find the highest base, which is 5. Minus 5 power n and divided by 5 power n. The answer will be coefficient in front of the highest base. This is, then we multiply minus 1 divided by 1, right? You multiply the term, the answer of the question 18 will be minus 1/3. Here. Okay. You will see that most of the question in this worksheets, like process almost the same. But if we apply that process to this one, we plug it in at first, you get infinity minus infinity over infinity minus infinity. And you said, okay, let's do the shortcut. If you're taking the shortcut, highest degree term is 1/2, right? Then you get √3 minus √3 divided by √1 minus √1, 0/0. It doesn't work, okay? If it be like this, it doesn't work with the shortcut method. You have no option, you need to conjugate, all right? I'm gonna write out the conjugate in the next page. All right, and you should find available space. Now, let you take note first, and I will write out another one page with the conjugate of the question 20. Alright. The conjugate to the term, to the functions of the limit is a little bit different to like the basic conjugate, because the basic conjugate, it like mostly it's happened with the bottom part term, right? With the bottom part of the function. And then we said, okay, if the function contains the radical form, you multiply conjugate to get rid of the radical form of the bottom part. But this is no. When we do conjugate with the limit, you see like any position, like no matter what, top part or the bottom part of the fraction that contain the root form, multiply conjugate to all term. Okay, like this. I need to multiply the conjugate here. I get √3n plus 2 plus √3n plus 1. Right? Now the first term conjugate, and you do the same thing with the bottom part conjugate. You multiply √n plus 2 plus √n plus 1. Okay. You may have another process in your mind. For example, ones that if you study it extra for this topic, we have another one type of process I call L'Hopital. The L'Hopital things doesn't work with this too. Okay, next question. A conjugate. Once we do the conjugate, you don't need to conjugate. You don't need to multiply, find the product of every term. Okay, just focus on the terms that be the problem to us, which is the negative term right there. Then I'm going to multiply only the highlight one, multiply this one with this one, and also this one with this. The rest of them just leave the term, no need to like simplify. Okay, let's see how's it work. If you do like that, this is complete square, right? You got 3n plus 2 power 2 minus 3n square root 3n plus 1, and then to the power 2 term, right? All right, and you multiply the term that we're not gonna do finding the product is root n plus 2 plus square root n plus 1 divided by, in the bottom part, root n plus 2 power 2 minus root n plus 1 to the power 2 and multiply root 3n plus 2 plus square root 3n plus 1. Okay, seems like we almost there, because if you see the number this part, only the positive side right here, no matter what you put the number in there or infinity in there, you can claim the answer for sure. Then we simplify just this term. The term is the bracket here. If we simplify those terms, you get 3n plus 2 minus 3n minus 1, isn't it? And divided by n plus 2 minus n minus 1. Right? And that term, leave it, it's going to be the same. Yeah. Right. Okay. Now we get this part. I think we are ready to simplify the term. Check. 3n plus 2. 3n minus 3n becomes 0. Plus 2 minus 1, then you get 1, right? n minus n, 0. 2 minus 1, then you get 1. Then 1 over 1 equal to 1. No need to do. Okay? After that, you reach these steps. Plug it in infinity one time. Take the limit to this term. You take the limit to this term, you will see that, teacher, it's infinity over infinity once again. What we're going to do? Shortcut method. Now we do the shortcut. If you do shortcut, it will be the coefficients in front of the degrees, right? Which is root 1 plus root 1 divided by root 3 plus root 3. Right? We're almost there. Because this is equal to 2. This is equal to 2. And the bottom part here, it's 2 square root 3. 2 and 2 you cancel, conjugate another one time. That's the answer of us. The answer will be root 3 divided by 3. That's it. Then you take note. Right? Then let's just not more than 5 questions for this worksheet for you to do. The rest we already complete. Okay? Okay, note first. After we finish taking note this one, I will pop up the limit through the numbers and also the infinite series. Okay, seems like, yeah. Okay. Thank you. Okay. To the next page is about the infinite series. Once we have the infinite sequence, when we sum those sequences together, it's going to be the series, right? Then infinite series being there if you sum the infinity term of the sequence. Okay? if you want to find the limits, if you want to find the sums of the infinity term, you could take the limit through the n term, and then you let your n to be infinity. Okay? Once we can define the number from the series, we say this series is convergent. But if we cannot define the value, no limit, we say divergent series. The same to the sequence. Okay? Then let's check out from the previous semester that we know the summation of n terms of arithmetics and the geometric, right? From the arithmetic series, always divergent. Except you let your first term to be 0 and then let your common difference to be 0. Then we can find that this is converge at the 0. Okay, but the rest is divergent. Yeah. But different to the geometrics, because in the geometrics, we got a common ratio, right? We got a common ratio. And the common ratio will make the term like increase or make the term be decreased, right? If it look like that, then we could check from the common ratio. Okay, we could check from the common ratio. For the geometric series, if the common ratio, absolute of the common ratio less than 1, then we could find the numbers. Okay? And if we check that the common ratio less than 1, it will be convergent at that point, but equal to what? Equal to a1 over 1 minus r. This is the formula of infinity term. Sum of the infinity term is a1 over 1 minus r, where r, absolute r, must be less than 1. But if it's greater than or equal 1, it will be divergent. Okay? For example, like this question. 4, 2, 1, 1 over 2, 1 over 4, 1 over x, you find the common ratio. The way that we're finding the common ratio, you're going to take like second term divided by the first term, or else the third term divided by the second term. Okay, I would do the third term divided by the second term, and I have 1 over 2, right? Now I'm going to check that, okay, absolute 1 over 2 less than 1. It will be look like this. Then I can apply s infinity, which is a1 over 1 minus r, for finding the sum of infinity term. My a1, the first term, equal to 4. Common ratio is 1 over 2. Finally, we get 8. The sum of the term to the infinity equal to 8. For the example 10. Okay. Not only this kind of series that have the answer of infinity term, but we do have another one thing, so the series I call telescoping, which is the really last 2 pages of last semester that we could define by using the limit. I would write it down and tell you. Is it example 10 in? Oh. ของขวัญต้นข้าวกินโชคข้าวปั้นข้ามบ่ายไปหาอาจารย์อยู่ห้องทำงานนะ Alright, teacher will show you another one example, okay, to the telescoping. Just in case that you see this one in the exam, then you will know how to do. No? Maybe not my exam, maybe the other exam. For example, if I give you, okay, let's find the sum to the infinity terms of 1 over 2 times 3 plus 1 over like 3 times 4 plus 1 over 4 times 5 and so on to the infinity term, right? But we said from our theorem we must find the limit, right? We take limit to summation of n term. and then we're going to let our n to be infinity. It means you're going to define the n term, right? In this question, this is called telescoping. The way that we're going to say that, look through the bottom part of the fraction. If you separate the number 2, 3, 3, 4, 4, 5, common difference is 1. 2s and 3, 3s and 4, 4s, 3s and 4, 4s and 5, common difference is 1. It will be 1 over the products of arithmetic sequence together. Okay? Then we could find that. How? Expand them. Okay, you're going to expand them. Let's take a look. If we continue to write it down to n term, then you tell me. What is the n term of this?
1 over 2.
1 over, 1, 2, okay, let's say 2, 3, 4, 5, finding the n term. This is arithmetic. It will be n plus 1, isn't it? Right? N plus 1. Where has it come from? an equal to a1 plus n minus 1d, right? The common difference is 1, then it's equal to 1n, and I want 2 plus 1. Arithmetics, general term, right? And if you look into only this part, 3, 4, 5, 3, 4, 5, plug it in, right? an will be equal to a1 is 3 plus n minus 1, common difference is 1. Finally, you get n plus 2. This is general terms of the sequence, right? And continue to the infinity term, right? But when we're writing down, we take the limit through the n term. It must be taking the limit to here, to our n term, to our Sn. Simplify the Sn first, okay? Simplify the Sn first. If you simplify Sn, you're going to get this one, 1 over 2 minus 1 over 3. Check ก่อนนะ 2 times 3 is 6. Cross 1 over 6. Okay. Plus 1 over 3. I separate 1 over 3 and 1 over 4. I separate 1 over 4 and 1 over 5. I get this until the n term. Okay. Till the n term. What? If you do it to the n term, it will be like plus 1 over n plus 1 minus 1 over n plus 2. Right? Okay? And after that, what else we could do from our n term? Minus 1 over 3 plus 1 over 3 cancel. Minus 1 over 4 plus 1 over 4 cancel. It's got to be minus 1 over 5 plus 1 over 5 minus 1 over n plus 1 in here. Then you have this and this. That's. Then you take the limit. Okay? Then you guys take the limit to this term. You get 1 over 2 minus 1 over n plus 2. If you take the limit to here, limit of the constant, you get the constant value. 1 over infinity turn to 0. The answer is 1 over 2. Okay? This is the way we apply our limits to the series. Huh? ถามก่อนว่า2 หน้าสุดท้ายของเทอมที่แล้วมันคือเรื่องนี้ได้เรียนหรือเปล่า ปล่อยเบอร์ไปเลยเหรอ สอนไม่ถึงหรอ อันนี้มันเป็นเลขแบบซีรีส์ซีเควนต์มันจะรวมร่างกันแบบ arithmetic รวมกับ geometric and geometric อะไรอย่างเงี้ย
สอนถึง
ถึงนี่ไงยินบอกถึง
ก็ยังสอนอยู่เลยว่าสูตรมันมีอะไรบ้างมี d เป็น n ลบ1คูณ d บวก a อะไรอย่างเงี้ยจำได้ไหมคะ
Yeah, it means you already learned that. Fine. It's fine. When the questions come, I will explain like questions by questions. Don't worry. Nah. All right. That the series, infinity series. And you will see that, okay, this kind of job, like when it comes to the sequence in the series, then we put the number to the infinity, right? But if we want to know the limit of the numbers that not infinity, what are we going to do? you're going to take the limit through the number, to exact number, right? And then we're going to adjust the terms once again. But when you put the limit through the number, it's like we're fighting. If it's in terms of domains and the range, because the functions come with fx, right? Fx is mean the functions give you that the domain, you plug in the domain, you get the value going to be the range. We're looking for the range, okay? Then let's deep to the details of our limit by using graphical method, okay? Normally, any function that we going to say that, okay, this function has the limit, or the limits can be defined, then what we going to check? We check from the left hand limit and the right hand limit. The left hand limit, it means the number of, let's say if I have limit of fx and x approach to a with negative like this, it's not the minus a, but it's mean the left hand side of a. We call this one left limit. Left hand side of a, what does it mean? And also like right hand side of a. The right side limit, we said like fx, limit of fx when x approach to a positive. That's called right limit. What? And left and right, what does it mean? For example, if I have x equal to 2, left limit, it means the number will be less than 2 just a little bit. For example, less than 2, like maybe your x will be like 1.99999 and so on. Okay? The right limit, greater than, or let's say x must be greater than 2. But how is greater than? It's maybe look like this, like 2.000000000, and then 1. It may be like this. Okay, that's called the right limit. But when the left limit and the right limit approach to the same value, the same number, we say that one contains the limit. Okay? Look to the graph. In the figure 3.1, let's marking on here. I mark here x equal to minus 2. If your x equal to minus 2, you find the left limit of x equal to minus 2 and the right limit in order to find the limit of the function, right? The dot right here, it means the value of the functions f minus 2 equal to 2. Equal to 3, right? We read y equal to 3. When it's be like the right limit, it means it approach to the right, right? Approach here, right? The number will be greater than, a little bit greater than minus 2. It will be like minus 1.999 something. Then it will be close to this plot, right? Then our left limit this time will be equal to 3. Right limit. For the right limit this time will be equal to 3. But when it's the left limit, it will be like less than minus 2 a bit. It's going to like this side, right? It approach our y with this side. Then this side, it will here. It will approach number 1. Okay? What? Limits of the same function, but approach different numbers like this. We said this is no limit. Okay? And this function has no limit. Let's say like this. Or limit can, This function, no limit. Okay? But if we change the plot, to here, x equal to 1, you will see that when x equal to 1, left limit, now I'm going to write down, if you write out the full term, it's going to be like this, like limit of fx, x approach 1 left. This will be equal to 2, isn't it? Because you read x and then you read y. It's equal to 2. And the right limit of f(x), x approach to 1 plus. What? This side come with this side, still the same. It approached number 2. Then you said, okay, we have the limit for this. This function has the limit, but this function is undefined. Why? Because here, the circle dot here, it means we didn't count this one, right? No, because it's not a bold one. We're not gonna count this as a number. No matter what, you get the limit. No matter what this function, but it's undefined. But the function f(x) undefined. Okay, because this dot, it doesn't count. All right. Some function has the limit, some function may not, but the function could be undefined. Okay, like this case. If it be undefined like this case, we say it, this is discontinuous function, Okay, we're going to mention about the continuity in the next class, which is tomorrow. For today, come inside for the class attendance and have lunch.